XSS or cross-site scripting is the #1 most common vulnerability in web security, even in 2019 after 25 years of the invention of websites. It is indeed Web Security 101 and everybody regardless of developer or user must know about it. XSS is in a narrowed way to say injecting malicious code into a website externally, or in other words, abusing a feature of a website so that the website is forced to run external code alongside with the server code, hence the name cross-site scripting. The main concept is easy and doesn't require intense hacking skills or programming like in the movies, rather just some common sense and knowledge about how the websites really work. In order to know how websites work, we need to know about HTML or Hypertext Markup Language. I assume you already know what HTML is in case you have any slight ambition on web development or web security. But for those who don't know, it's just a simple language. Mind that I said language, not code, to let a browser know what to show to the user. Normally, the server sends the pre-written HTML to the user, filled up with the data from a database or a dataset. But in modern days, since the websites are more developed, the user can also fill up the HTML file and send it to the server as well. And it's at this moment where we step into the dangerous world. HTML is just a tag-based markup language. It's just like written words in a text editor, but different tags are used in order to format or organize the whole page of a website. The tags are defined with two angle brackets, like you see here. There are two HTML tags for each piece of instruction, the opening tag and the closing tag. The difference between opening and closing tag is that the closing contains a / in front of the tag name. Anything between these two tags will follow specifically the instruction given by the tag, which are known by the web developer during web development. For example, by using the bracket B tags, the developer meant everything between this and this must be bold. Similarly, I for italic, sup for superscript, etc., and thousands of other tags. One of such interesting tag is the script tag. The script tag lets the browser know that everything in between these tags is not just HTML, rather it's JavaScript, a browser or client-based programming language which must be trusted and run by the browser, also known as the JavaScript engine. The JavaScript, unlike HTML, is not shown to the user, rather is run by the processor and the result is then shown, posted, maybe just runs in the background. Now JavaScript is incredibly powerful and it can do some incredible stuff, which makes them incredibly dangerous. Let's come back to HTML for a moment. In HTML, we can use form and input tags to let the browser know that hey, the user is supposed to type data here into me and press the submit button to submit the data to me. This happens and we submit the data to the server and the server responds according to that data. Here, as you can see, it just reflects our name and it says nice to meet you afterwards. So what if we don't play by the rules and rather send something that we are not supposed to send to the server? Like what if we send a B tag, like B Zuhair instead of just Zuhair? Well look, now everything after my name has become bold since the server thinks B is a part of the code. And since we never closed it, everything after that must be bold. We can do the same with I or anything, and perhaps you can get creative and design the whole page just as you like, using the same method but different tags. Yay, we hacked the website. Well, not quite. We can do something even dangerous. What if we send a script tag? Let's try sending script alert something and the ending script tag. Now before we send it, let me just explain what's going on. As we know from before, everything between script and ending tag will be treated as JavaScript, since we already proved it using the bold tags. Now inside JavaScript, we wrote a function called alert, and as an input to alert function, we provided the string something. So what something does is it calls a default browser behavior called alert, which pops up a message showing whatever is given as input. As you can see, after we click here, the website is now popping up a new message called something. It might not seem like much, but we actually ran our own code inside the website. Well, I'm sure most of you are now thinking, well, that's great, but why? Only I can see and run that code and it doesn't do anything other than just saying something. Well, here's where you get creative. We now replace alert with something else. Maybe we use a source tag to inject a larger malicious code into that place. Or even better, we use a stored XSS attack. Stored cross-site script means we hide our script as a text or a comment in a post or something. Let's take Facebook for example. If you inject this code onto a Facebook post's comment, everyone who sees that post, their web browser is gonna think that the script tag inside your comment is actually a part of the website and execute that script. So everyone gets their password stolen, or being more harmless, everyone gets a something message pop up out of nowhere. So rush on the YouTube comment, script, alert, hello, script, and also the Facebook comments, go! Well, now that you've tried, it definitely didn't work, did it? Of course it didn't, because people working at Facebook are smart enough to detect such attacks and mitigate them. They do it by sanitizing the user input. Sanitizing means they tell the server that do not trust what the user sends. Rather save it and change it, maybe all brackets change into something like %LT and replace them later when showing them, or do whatever you want, but do not run the code. Basically, they explicitly write code to prevent you from writing code. But this is where it gets interesting. It is very easy to miss such sanitization in all user input fields. It is an incredibly difficult task to make sure all user inputs is sanitized, from post comments all the way to just the search bar. And that's why cross-site scripting is the #1 common vulnerability in the world. And it is so common and so dangerous that big companies are often hit by it, and they often host bug bounty programs where you can report such a vulnerability and they will actually reward you with around $10,000 for finding and reporting the bug. But again, we are all humans, capable of making mistakes and rectifying other mistakes. Even if you sanitize inputs, there are still thousands of ways to bypass the filters or still get your code run, which is a huge topic by itself. If you're interested, check the description for some useful links and resources. Among them, the XSS introduction by Tom Scott, his talk about the self-retweeting tweet, OWASP resources, and others especially mentionable. If you enjoyed this video, make sure to leave a like down below and share it to your friends if you find it interesting. See you soon in the next video of Scattered Whippersnappers.